Hello, pre-algebra students. We're going to lump section 4 and 5 of chapter 6 together in this video, and we're going to talk about ratios and proportions. Let's first define a proportion. A proportion is an equation stating that two ratios are equal. Another word for ratio is fractions. Two ratios or fractions are equal. So our first example here asks to determine if the ratios are in proportion, if they form a proportion. To be a proportion, 3/6 needs to simplify down to 1/2. And as we know, we can divide by 3, divide the top by 3 and the bottom by 3, and that does simplify down to 1/2. So is 1/2 and 3/6, are they in proportion? And the answer is yes, because they both simplify down to 1/2. Let's check 1/3 and 7/12. Well, 7 does not go into 12 evenly. I can't think of a number that goes into both 7 and 12, so no, 1/3 and 7/12 are not proportional. What about 2/14 and 4/28? Well, it's going to be easier to simplify both. So 2/14, does that break down to the same thing as 4/28? For that one, we know 2 goes into both of these, so divide the top and the bottom by 2, and that gives us 1/7. And if I divide the top and the bottom by 4, 4 goes into 4 once, and 4 goes into 28 7 times. So yes, those ratios or those fractions are proportional. So this is basically 6-4 in a nutshell, determining whether they are proportional, and if they're not, they're called non-proportional. Now one more time, let's review what is a proportion. Let's go back to the definition of a proportion. It's an equation, okay? So they weren't given to me as an equation, but I set them up as an equation. It's an equation stating that two ratios are equal. So I'm checking to see if they're equal, and if they are not equal, then we say they're non-proportional. If they do turn out to be equal, then yes, they are proportional. So in example 2, this is where we start in on 6-5. It says, determine the missing number that should be used to complete the proportions. We're trying to make it a proportion. We want it to be true. So 4 over what equals 1/2? And that would be easy to say x is 8, because 4/8 simplifies to 1/2. That makes that a true proportion where the two ratios are equal. X over 8 equals 4/16. Well, 4/16 simplifies down to 1/4. So what over 8 would also equal 1/4, and that's easy. X would be 4. So 1/4 is our constant ratio of what our proportions should equal. Now these are both easy. We could solve these almost in our heads without having to do much thinking, but they're going to get more difficult. And as they get more difficult, you're going to want to use the property of proportions. You know this as cross multiplication. So you're going to either cross multiply, or sometimes it's called cross products, which when you go across, product means multiply. So you're either going to use cross multiplication or cross products. And here is the property of proportions. This is what we're talking about. A times D here equals B times C. I always refer to this as the Jimmy Neutron symbol. That's what cross products, that's how you solve those. You cross multiply and you set them equal. Why are they equal? Because they are a proportion. We're not asking the question like we did in the first example, are they proportional? We know they're proportional, so we have to determine what x should be. So for this problem, you'll cross multiply 15 times x equals 36 times 9. I need my calculator to make this go quickly. 15x equals 324. Divide by 15, and x equals 21.6. All right, I'm going to leave this one for you to cross multiply. Again, if you've got your calculator, the decimals are no big deal. And let's look at example 5 before we go. A serving of 4 crackers contain 70 calories. So 4 crackers contain 70 calories. How many calories? So I'm looking for calories. So my X here is calories. How many calories are in 7 crackers? So we're comparing crackers to calories, so I need to find out what X should be. So here I go. I'm going to cross multiply. 4 times X equals 7 times 70. So 4X equals 490. Divide by 4, and X is how many calories? And it's 122.5 calories in 7 crackers. Now, if they'd asked us how many calories per 1 cracker, we would have to then simplify. But that wasn't the question. It says how many calories are in 7 crackers. There are actually 2 ways to solve this. That's one way. Let me show you the other option. You could do crackers over crackers. 4 crackers are to 7 crackers. Instead of doing crackers to calories, we could compare crackers to crackers and then calories to calories. So see, 4 goes with 70, so 4 is on top, 70 goes on top. When you cross multiply, you still end up with 4X equals 490, and X will still be 122.5 calories. So when you set up a proportion, listen to this. It doesn't matter if you mix it up. I know when we did dimensional analysis, we were very adamant that we wanted kilometers to cancel with kilometers and there, so on and so forth. But when we're talking about a proportion, it's how you want to compare it. Are you comparing crackers to calories or crackers to crackers? So there are 2 correct ways. Both ways are equally effective. Okay, so my boys came in late this weekend. They missed their curfew, and I told them to be home at 11:45, and they came home at 3 o'clock in the morning. This is a joke. This is not for real, or they would have been grounded for life. Can you come up with a mathematical reason why they thought they shouldn't be in trouble if they came home at 3 o'clock and I told them to be home at 11:45? I'll give a good work to the first person who can mathematically solve my riddle. Have a great day.